All right, let's get right into it because today we're looking at a brand new theoretical paper that is just wild. It connects glowing bats, quantum physics, and sound waves all wrapped up in one of the coolest biological mysteries I've come across in a very long time.
So it all starts with something really simple and honestly, a little hard to believe. It turns out that under a UV light, certain types of bats, they glow. And we're not talking a faint glimmer, we're talking a vibrant, almost eerie green.
And that is the big question, right? The one that's got scientists totally hooked. I mean, this isn't just some weird party trick of nature. This glow could be a clue, a hint at a much deeper, way more complex story about how these creatures actually experience their world. So, why on earth do they do it? Okay, let's drill down into the specifics here. Recent studies have actually documented this green photoluminescence. We've seen it on the wings of at least 6 different North American bat species. And it's not random. It pops most intensely when you hit them with UV light, right around the 410 nanometer wavelength. And the glow is really concentrated on their wing membranes.
Now, before we get to the really out there theory that this new paper proposes, we have to do our due diligence. We've got to line up the usual suspects. Whenever biologists see an animal glowing, their minds usually jump to a few pretty standard explanations.
So when you boil it down, the glow could be coming from one of 3 places. First, it could be what we call endogenous chemistry. So chemicals like flavins or porphyrins that the bat's own body produces. Or second, it could be the microbiome. Yep, tiny bacteria living on the wing that create these glowing biofilms. Or, option 3, it might not even be chemical at all. It could be the wing's unique physical microstructure, just the way it's built, trapping and re-emitting light in a really special way. And this is where the paper just throws a huge curveball. It asks, hey, what if we're looking at this all wrong? What if it's not either or? What if this glow is actually the result of all 3 of these things, the chemicals, the microbes, and the structure, all interacting in one complex living system? And that question leads us straight to the core concept of the paper. The theory is that a bat's wing isn't just a flap of skin for flying. Nope. It's a dynamic, optically active interface that the author calls a live prism. So what in the world is a live prism? Well, think of it as a system where everything comes together. You've got the bat's own pigments, the physical texture of the wing tissue itself, and the chemicals being churned out by the microbes living on it. It's like a living optical system where all these different parts are working in concert to manage light. So how would this live prism even work? The paper suggests this incredible chain of events. Okay, step 1. The bat flaps its wings. This creates intense, super high-frequency vibrations. Step 2. These vibrations put physical stress on the microbiome, all those little bacteria living on the wing. Step 3. The microbes, in response to that stress, start producing these glowing pigments. And finally, step 4. This glow isn't just a random side effect. It could actually be a signal, either for other bats to see, or maybe for the bat itself. A signal for the bat itself, but a signal for what? All right, you're going to want to buckle up for this because this is where the theory takes a really speculative, kind of mind-bending turn. The paper proposes that this glow might be doing way more than just sending a simple message. It might actually be plugging into a bat's ability to navigate. To even wrap our heads around this, we need to talk about something called magnetoreception. It's a known thing in a lot of animals. We're talking birds, sea turtles, you name it. It's their ability to sense the Earth's magnetic field. It's basically a built-in biological compass that helps them find their way. And that right there leads to the most radical question in this entire paper. Is it possible that the light being produced on a bat's wing could actually influence or fine-tune this internal magnetic compass? The proposed link here is through these special proteins called cryptochromes. Now, these are light-sensitive molecules. They're often found in the eyes of migrating animals. And right now, they're the leading scientific candidate for how a biological compass actually works at the quantum level. The radical idea here is that the faint green light from the wing could interact with these cryptochromes, basically amplifying the signal from the Earth's magnetic field and making the bat's internal compass way more accurate. Look, a wild theory is great and all, but this is science, right? It demands proof. So, for me, the most impressive part of this paper isn't just the crazy idea. It's the incredibly detailed plan it lays out for how to test it. And, just as importantly, how to prove it wrong, and fast. The key to the whole thing is this proposed device called the micromaze. It's basically a tiny, perfectly controllable lab built around a small, safely biopsied piece of living batwing membrane. This would let scientists poke and prod every single variable in a totally controlled way.
And they are not messing around. The paper lays out this super aggressive 60 to 90-day falsify fast plan. The whole goal is to try and break the hypothesis, to prove it wrong as quickly as possible. The logic is just beautiful. First, you nail down the basics with the optics. Then you add sound. Then you mess with the microbes. And only at the very, very end do you introduce a magnetic field to test the big compass theory.
Let's break that down just a little more. So phase A is just about getting a baseline. What does the glow look like under normal, boring conditions? In phase B, they crank up the acoustic vibrations to see if sound actually changes the glow. Phase C is all about playing with the bacteria on the wing to confirm if they're really involved. And then only if the theory survives all of that do they move to phase D, the magnetic field challenge. It is just a perfect example of how you isolate variables in an experiment. So here's the kicker. What if the quantum compass idea turns out to be totally wrong? What if they get to phase D and the magnetic link is a bust? Well, the beauty of this whole research plan is that it almost doesn't matter. The investigation itself opens up completely new ways of thinking about bat biology.
I mean, even if you take the compass out of the equation, this glow could be doing so many other incredible things. It might be a form of short-range visual communication for bats huddled together in a roost. Or it could be an honest signal of an individual's health or stress level. It might even be some kind of low-energy sanitation system where the light helps keep the wing's surface clean. Any one of those would be a huge discovery on its own.
And that really brings us to the ultimate takeaway here. I want to end with this quote directly from the paper's author because it just sums it all up perfectly. Whether or not it tunes a quantum compass, this idea of a live prism on a bat's wing gives us a completely new window into their physiology, into how they communicate, and into the super complex world of microbes living on their skin. And that, right there, is what great science is all about, opening new windows we never even knew were there to look through.